block of code to make it move. It is just following the direction at this point. Are we doing okay so far with this program? Okay. So the next thing I want to do is just to make it move at a constant speed. Okay, it's not fancy. It will have a problem because when the sprite is at exactly where the mouse pointer is, then what is it going to do? It will keep flip-flopping because one move will move it beyond the mouse pointer, so the facing direction will be like exactly opposite. So it just kind of oscillate and have a little spasm problem at that point. But that's the easy logic to specify. We'll use the easy logic first, okay? Because we don't want to build a program to be the most complicated and the final version the first time. We want to add more stuff to the program as we go along and verify everything that we have done up to this point is correct first, okay? So that means we have to go to motion and just pick, move, a certain number of steps, after we point the direction to the mouse pointer. And let's make this, not as much as, 10 steps. Let's just make it move like 3 steps at a time so it doesn't go way too fast. And we can even put in a delay, go to here and put a wait right after this to make it even slower. If it moves slower, we can debug the program a little bit better. And let's not forget to put an end to this code, even though at this point it's not that important. We'll still put an end here. And now we are going to run the program. And you can see how the sprite is following the direction of the mouse pointer, but it's moving very slowly. Okay? So one thing we wanted to try is what happens when, do you see the spasm here? That's because when the sprite is exactly where the mouse pointer is, one move will move it like beyond the mouse pointer. It has to reverse the direction to face the opposite way, and then another move will move it beyond the mouse pointer again. Then it has to reverse and face the other direction, and that's why it keeps flip-flopping like this here. Okay? How do I stop it from doing the flip-flopping thing? Yep.
Conditional if it's touching the mouse to stop the movement.
Yep. Mm-hmm. But the other thing I want to test at this point is whether the program will in fact stop. Okay, when I touch the black line or when I touch the red line. So we'll direct the sprite to get out. Aha! It got out. Okay? Let's go ahead and run it again, and this time we get it all the way through. You can see that I'm having fun with my own program here. That's why I like this job. Licensed to play games in the class. Can't beat that.
Nope.
Yep. Okay. All right. Let's get it to the finish line, and it got out of loop. So the program worked. Okay, it got out of the loop. Whether it is touching a red line or the black line, it gets out of the loop. We'll deal with whether the message should be good job or game over later on. Okay, we can deal with that later. What I want to do right now is to make the motion of the sprite proportional to the distance between the sprite and the mouse pointer. Okay? If your mouse pointer is like this far away from the sprite, it will go fast. If your mouse pointer is only this far away, it will go slow. Okay? So this way you have some sort of velocity control over how fast the sprite is going to navigate around the maze. Okay? And this kind of goes back to the autocross thing, because this is basically sprite autocross. How fast can you get through the cones? I should use cones instead of a black line because that's how autocross races use. They just use cones. Okay, so we'll go ahead and change the program a little bit because what I'm going to change now is how many steps to take, in every iteration. Okay, instead of a constant 3. We want to change it a little bit. We want to change it so that it is proportional to the distance between the mouse pointer and the sprite itself. It sounds like some complicated calculation. We have to find out where the sprite is, where the mouse is, do the distance calculation, which involves squares, addition, and the square root, and then we have to multiply that to a multiplier, a constant of some sort to get the result. It's actually a whole lot easier than that. because we can go to looks. Well, is it looks or motion? I think it's one of these two. We are looking at, let's see, maybe sensing. Let's see. Okay, that's the position. Distance 2, excellent. Okay, now if you look at this thing here, I will just drag it over here. What is the shape? It's a little bit harder for you guys to see because the contrast of the screen is not really that good. Okay, I'm hoping that most of you can see that it has a rounded edge around it, which means it is a numerical value. Okay, a numerical value is like 0, 10, 20. It's just a number, which means I can perform some sort of calculation on this number. I can multiply that by 0.1 or 0.01 to give me another number. That's great because that's exactly what I need. Multiplication is an what? Is it motion, looks, sound, pen, control, sensing, operator, or variable?
Operator.
Operator, very good. So we look under operators, and multiplication for computers is the asterisk symbol, not the cross symbol. Can someone kind of give me an idea or guess why that is the case?
Because the cross symbol is for x, and x is a variable.
Correct, because if it had the correct multiplication symbol, it will look too similar to the lowercase x letter, which is not how we want it to be, and therefore we use the asterisk symbol on the keyboard to mean multiplication when it comes to programming. Okay, so what we need to do is to say, I want to measure the distance to the mouse pointer and just multiply it with a particular factor. I don't know exactly what factor would be used. It would be right. So we'll start with something that's small, okay, like 0.01. And then we'll drag this entire calculation back into, the 3 here to replace the 3. So this time, instead of moving a constant of 3 steps every single time, the distance is going to move depends on the actual distance between the sprite and the mouse pointer. Okay? The larger the difference, the faster it will move. The smaller the difference, the slower it will move. So let's go ahead and try out this program and see whether it works. Oh yeah, except the constant I pick is a little bit too small. But you can definitely see that it slows down when the mouse pointer is closer to the sprite, and it speeds up again when the mouse pointer is far away from the sprite. Okay, well that's good. Now I can stop the program, and what I need to do is to change this constant so that it is not going at a snail pace. 0.5 is already 5 times, so that's probably a good speed for a game, something like this. Ding. Cool. Huh?
That's cool.
I mean, it is really that easy to put a really simple-minded game together just like that. Okay? Now, your program on the stage can actually change the bitmap itself. Okay? There are several ways to change the bitmap or the background of the stage. You can have a sprite to draw that. In other words, you can have autocross helpers coming out to reorganize the cones. Okay, that could be a little fun thing to do too. To randomize it a little bit and make sure it is still wide enough for the sprite to go through. Or you can just load something from a file. You can just load from a bitmap. Okay, so my game is almost done, except it doesn't have the engine sound and whatnot. And that you can do too. Remember, we have audio control under looks of sound in this case. So you can actually go to your own car. If you have a nice car with a nice exhaust note, you can just record that sound. Now, not only can you do that, you can also make it so that it is conditional to this number here, distance to mouse pointer. In other words, when the distance is far away and it has to go fast, you pick a different sound from your samples. Okay, so you might have the turbo, spooling up, and stuff like that. You can make this game, really as fancy as you want it. I mean, this is like bare bone basic at this point. You can even have your mouse or your icon. You can detect what kind of turn it's making and how fast it's making the turn. In other words, if it's making a turn really fast, you can say, oh, I better leave some tread marks behind. You can do that. Okay? The easiest way to do it is to use the pen down option and just just say, if you're making a turn too quickly, put the pen down so it will leave some skid mark behind when it's making a quick turn, or when it's accelerating really fast, it will also leave some skid mark behind. That could be fun. I mean, that could be interesting. And you can also change the sound, the audio, to reflect the screeching of the tires. I mean, the sky is the limit, cool, even for simple-minded games like this. Okay. So now we'll go ahead and specify the conditional statement after the loop to display either game over or good job. Okay, you finished it. What do we need to display game over if the sprite touches black, or to display good job if it touches red?
You need a conditional statement that says if it's touching black, then go to this program. If it's touching red, then you need to go to the other.
Okay.
And else statement.
An if then else statement, yes. An if else statement is what we need. So we'll go ahead and take a look at the if else statement and see how it works and how it's slightly different from the other if statement that we have seen so far. This is the if else statement. It looks a little bit different from the if statement because there's an else portion here. So what happens here is this is still a condition, it's still a hexagon, which means it is still specifying a true-false value. But this time, if this value is true, it will go execute whatever is between the if and the else. If the condition is false, on the other hand, it will execute whatever is after the else. In other words, if you look at the picture that we had before, where we had the empty branch that has nothing to do, now we can specify something to do with the other branch as well. But the most important point is either after performing this action or this action, it will continue on to the next statement, to the next construct. It does not go back. You don't see a little symbol to go back like a loop does. Like this one here, like this one here, these will go back. A conditional statement does not go back by itself, even though it can be a part of a loop that can go back because of the loop itself. Okay, so we'll go ahead and specify a conditional statement here, and the end will go after this. Just like that. And we can specify something like, like an operator. No, we don't want an operator. We just want the touching part here first. Okay, so we want touching color. We'll put it here. And we specify if it is touching black, then we say game over. Okay? So we'll go ahead and use looks and, put a say bubble here. And say for 10 seconds, game over. Okay? Now, you can make the game a whole lot more complicated by saying, oh, touching the black once is not a problem. Okay? It's only game over if you touch the black like 5 times or give it a number of times. So that way, it complicates the logic quite a bit because now you need a counter again. You need a counter to count how many times the sprite has touched black. And then, if it is more than 5, then you say game over. You have to get out of the loop, and then you say game over. If it is only 4 or 3, you can change the time. Okay? In other words, just like with a real autocross race, if you touch one cone, it is 1 second penalty. Okay? So you can complicate the logic of this program, on little things like that. But I'm just going to make it simple-minded at this point. Now, technically speaking, because we can only get out of the loop either because it is touching black or it's touching red, by the time we get here, if it is not touching black, it has to be touching red. But if you write a program making that assumption,